Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss Class 12th Physics Alternating Current, Chapter 7 NCERT Solution, Part 10. Please subscribe, like and share our channel if you have not done yet. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Please give us a like sign and write comments on our video. Today we'll start with question number 7.23. A power transmission line feeds input power at 2300 volt to a step down transformer with a primary windings having 4000 turns. What should be the number of turns in the secondary in order to get the output power at 230 volt? Let us see the solution. 7.23. So this sum is based on the basic formula where voltage is related to the number of turns as V1 upon V2 is equal to N1 upon N2, where V1 and V2 are the voltage input and output voltage, and N1 and N2 are the number of primary and secondary turns. Now, if we know this formula, then this sum is very easy. So please learn this formula. Let us solve the sum now. Input voltage, input voltage V1 is equal to 2300. Number of in primary coil N1 is equal to primary coil N1 is equal to 4000. Output voltage output voltage V2 is equal to 230 volt. Number of turns turns in secondary coil is equal to N2. Voltage is related is related to the number of turns as V1 upon V2 is equal to N1 upon N2. So putting the values, we get 2300 upon 230 is equal to 4000 upon N2. Therefore, N2 is equal to 4000 multiplied by 230 upon 2300. So cancelling this, this is by 10. So we got 400. N2 is equal to 400 turns. So hence, hence there are 400 turns in the second winding. Let us see the next problem. The next problem is 7.24. At a hydroelectric power plant, the water pressure head is at the height of 300 meter and the water flow available is 100 meter cube per second. If the turbine generator efficiency is 60%, estimate the electric power available from the plant. G is equal to 9.8 meter per second square. Let us see the solution. Problem number 7.24. Height. So first step is 1. Step 1 summary. Write all the given values in the sum. All the values which are given in the sum. Step 2 will be the implementation of the formula. So power available in the plant is equal to neta, the efficiency, multiply by h, height, rho is the density, g is the acceleration due to gravity, and v is the volume. of water that is flowing per second. So put the values, all the given values in this formula, we'll get the sum. We'll get the answer. So let us solve this sum. First step, we'll write all the given values. So height of water pressure, height of water pressure, head, h is equal to 300 meter. Next, volume of water flow per second. V is equal to 100 meter cube per second. Efficiency of the turbine of turbine generator N is equal to 60% is equal to zero point 0.6. Acceleration due to gravity is equal to uh, acceleration due to gravity G is equal to 9.8 meter per second square. Density of water rho is equal to 10 to the power q kg per meter cube. Now, electric power available from the plant is equal to neta multiplied by h rho g v. You have to remember this formula. So zero point 0.6 multiplied by 300 multiplied by 10 to the power 3 multiplied by 9.8 multiplied by 100. Upon solving, we got 176.4 10 to the power 6 watt, which we can write 176.4 megawatt, and this is the answer. The next problem is 7.25. A small town with a demand of 800 kilowatt of electric power at 220 volt is situated 15 km away from an electric plant generator generating power of 440 volt, the resistance of the two-wire line carrying power is zero point 0.5 ohm per kilometer. The town gets power from the line through a 4000 220 volt step down transformer at a substation in the town. A. Estimate the line power loss in the form of heat. B. How much power must the plant supply assuming there is negligible power loss due to leakage. Let us see the solution. Oh, part C is also there. Characteristic characterize the step up transformer at the plant. So let us see the solution. So question number 7.25. Step 1 to solve this sum will be summary. In a summary, we'll put all the given values of the physical quantity which we know from the problem. Step 2 will find the RMS value of the current of I. So once we get the RMS value of I, we can proceed to find out power and other things in simple steps. So power is equal to I square R power loss is equal to I square R and other small formulas are used to solve A, B and C part of the sum. So main thing is to find out the root mean square value of the current. So now uh, so in the step 1 we have to write the summary of the sum. So total electric power required P is equal to 800 kilowatt, which is equal to 800 into 10 to the power 3 watt. Supply voltage supply voltage V is equal to 220 volt. Distance between the town and power generating station is equal to uh, D is equal to 15 kilometer. Resistance of the two wire lines carrying power is equal to zero point 0.5 ohm kilometer. Total resistance of the wires R is equal to 15 plus 15.5 is equal to 15 ohm. A step down transformer of rating 4000 by 220 volt is used in the substation in the substation. So input voltage V1 is equal to 4000 volt. Output voltage V2 is equal to 220 volt. RMS current in the wire lines is given as I is equal to P upon V1, which is equal to 800 multiplied by 10 to the power 3 upon 4000 is equal to 200 ampere. Now let us see the problem A. Line power loss is equal to I square R, which is equal to 200 square multiplied by 15, that is, upon solving, it is 600 10 multiplied by 10 to the power 3 watt, which is equal to 600 kilowatt. This is the answer. Now part B, assuming that the power loss is negligible due to leakage of the current, total power supply by the plant is equal to 800 kilowatt plus 600 kilowatt, which is equal to 1400 kilowatt. Now this is the answer. Now part C, voltage drop in the power line is equal to IR, which is equal to 200 into 15, which is equal to 3000 volt. Hence, total voltage transmitted transmitted from the plant is equal to 3000 plus 4000 volt, that is 7000 volt. Also, the power generated is 440 volt. Hence, the rating hence the rating of the step rating of the step up transformer situated at the power plant is 400 volt 700 volt. And this is the answer of part C. Let us see the next question, next problem. And now we'll solve the last problem of this chapter, that is 7.26. Do the same exercise as above with the replacement of earlier transformer by a 40,000 by 220 volt step down transformer. Neglect as before the leakage loss through this may not be a good assumption any longer because of the way of the very high voltage transmission involved. Hence, explain why high voltage transmission is preferred. Let us see the solution. So, question number 7.26. So, step 1, we'll write the summary of the sum. Means all the given physical quantities value, we'll write it as a summary. After that, we'll find the power. Rest of the rest of the the steps is same as of 7.25. So let us begin with the first step by writing all the given physical quantity. So we can write the rate rating of a step down transformer is 40,000 volt by 220 volt. Input voltage V1 is equal to 40,000 volt. Output voltage V2 is equal to 220 volt. Total electric power required is equal to uh, P is equal to P is equal to 800 kilowatt, which is 800 multiplied by 10 to the power 3 watt. Source potential V is equal to 220 volt, voltage at which the electric plant generates power. Power is equal to V dash is equal to 440 volt. Distance between the town distance between the town and power generating station. D is equal to 15 kilometer. Resistance of the two wire resistance of the two wire lines carrying power is equal to zero point 0.5 ohm per kilometer. Total resistance of the wire line lines R is equal to 15 plus 15 multiplied by zero point 0.5, which is equal to 15 ohm. P is equal to power P is equal to V1 I. RMS current in the wire line is given as I is equal to P upon V1, which is equal to 800 multiplied by 10 to the power 3 upon 40,000, which is equal to 20 ampere. Now A, line power. Line power loss is equal to I square R, which is equal to 20 square multiplied by 15, which is equal to 6 kilowatt. This is the answer of part A. Part B. Assuming that the power loss is negligible, due to the leakage of current. Hence, power supplied by the plant is equal to 800 kilowatt plus 6 kilowatt, which gives 806 kilowatt, and this is the answer of part B. Now part C, voltage drop in the power line. In the power line is equal to IR. V is equal to IR. So is equal to IR, which is equal to 20 multiplied by 15, that is 300 volt. Hence the voltage hence the voltage that is transmitted by the power plant is equal to 300 plus 40,000 is equal to 40300 volt. The power is being generated in the plant at 440 volt. Hence the rating of the step up transformer needed at the plant is 440 volt 40,300 volt by 40,300 volt. So the power loss hence the power loss during during transmission is equal to 600 by 1400 multiply by 100 is equal to 42.8%. In the previous exercise, power loss due to the same region is due to the same reason is 6 upon 806 multiply by 100, that is 0.744%. Since the power loss is less for a high voltage voltage transmission, high voltage transmission transmissions are preferred for this purpose. So this is the end of this chapter. Please subscribe, like, and share our YouTube channel. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Please give us a like, comment on our videos if it is benefited, and please write us your views on the videos. Thank you very much, and thank you for supporting us.